Hi, today's lesson is an algebra lesson. The topic for this lesson is types of numbers. During this lesson, I'll be utilizing the reading strategy, brainstorm, and categorize. This reading strategy can be found in Laura Robb's teaching reading in social studies, science, and math. Good morning, class. I'd like for everybody to take out a piece of paper and a pencil. And I want you to write down any word that comes to mind when you think of types of numbers. During this portion of the lesson, it would be just a review. Students would have to use prior knowledge, such as from previous lessons in this class or even other math classes. They won't know the types of numbers we're going to learn today, so they'll write down things such as odd numbers, even numbers, negative numbers, positive numbers, fractions, and decimals. After each student has finished writing their list, we'll brainstorm as a class and write them all up on the board. We'll go over and have a discussion on the types of numbers that they've come into contact with before today's lesson. After we've done that, I'll have students read the chapter in the book that deals with types of numbers. While they're reading, they will come up with the 6 categories of types of numbers we'll be dealing with. Those 6 categories are real numbers, integers, whole numbers, natural numbers, rational numbers, and irrational numbers. As students read, they'll figure out the definitions for those 6 types of numbers. For instance, integers are whole numbers that are negative, 0, or positive. So things such as -5, 0, and +5 are all integers. Then there's whole numbers. Whole numbers are just what we think of. They're 0, 1, 2, 3, 4, so on. All the whole numbers. Then there's natural numbers. Natural numbers are counting numbers. So when we count, we start with 1, 2, 3, 4, and so on. So they're all the whole numbers that don't include any negative numbers or 0, since we don't count anything with negative numbers or the number 0. Then we have rational numbers. Rational numbers are numbers that can be written as a fraction. So of course fractions will be rational numbers. Then we also have decimals. But the only types of decimals that we'll use for rational numbers are terminating decimals. That means that you can see the end of the decimal. So 3.45 is a terminating decimal and would be considered a rational number. Then there are the repeating decimals. Decimals such as 2.45, 45, 45. Sometimes you'll see those as 2.45 with a bar over them. And then there's irrational numbers. Irrational numbers, there's 2 types. There's the number pi, and there's non-terminating and non-repeating decimals. So those are the decimals. When you type them in on your calculator, it'll be like 3.487925, and it'll keep going. Sometimes you'll see it with the 3 dots after a certain amount of numbers, so that you can tell that the decimal is non-terminating, and there's no pattern, so it's non-repeating. And then there's real numbers. Real numbers are any number. So all the different types of numbers fall under the real number category. All integers, whole numbers, natural numbers, rational numbers, and irrational numbers are all real numbers as well. So students will come up with those 6 categories, and I'll have them write them on a piece of paper just like this. They'll have their 6 categories so that we can look at numbers and categorize them together. So every student will get a piece of paper with 18 different numbers on it. They won't know what these types of numbers are, but they'll work in partners to categorize these into our 6 categories we came up while they were reading. So as they work in partners, I'll walk around the room and make sure that they're categorizing them correctly. And then we'll go over them all as a class together to make sure that every student knows exactly which category has which numbers before we have an assignment on it. So for instance, let's go over a couple so we can show how that would be. The first number on the list is 7.47. So if we look at 7.47, we notice that's a decimal. So we obviously know that goes into real numbers because all numbers are real numbers. Then we want to look at, is it rational or is it irrational? So we know that terminating and repeating decimals go in rational. And since we can only see 7.47, there's no 3 dots after it trying to say that's non-terminating, we know that this decimal is a rational number. It is not irrational. It's not a natural integer or whole number because it's not a whole number at all. Those 3 categories have to be a whole number. So the only two categories we can put 7.47 under is the real numbers and the rational numbers. Then we have pi. So pi is a rational number. It is also a real number since all numbers are real numbers. So the only two categories that one will go under is the irrational and the real numbers. Since pi is basically in the definition of irrational, any number that has pi in it is going to be considered an irrational number. Because pi is actually a non-terminating decimal. Pi, usually we see it as 3.14, but it's actually 3.14159, 26535, and it keeps going on and on forever. So it is actually a non-terminating decimal, which is why it is considered an irrational number. Alright, the next number we have is -1. So we automatically see that's a whole number, so it won't be under rational or irrational numbers. Then we want to look at the categories such as natural, integers, and whole numbers. Alright, so our natural numbers are our counting numbers. So we never count anything with -1. So it would not be considered a natural number. It's an integer, so it would be considered an integer, since integers contain the negative whole numbers, positive whole numbers, and 0. And it also is a real number since we've determined that all numbers are real numbers. Alright, then we have 0. 0 is obviously a real number since all numbers are real numbers. It's not a natural number. When we count things, we do not use 0. It is an integer, and it is a whole number. So we have those under integer, whole number, and real numbers. Right, the last example we'll go over is 2/3. 2/3 is obviously a fraction, so we can automatically assume that's under the rational numbers because rational numbers definition is that it can be written as a fraction. 2/3 is part of a whole, so it's not a whole number, so it would not be under natural, integers, or whole numbers. It would be under real numbers since all numbers are real numbers. So after we'd gone over all the 18 examples, then we could assign students a worksheet that dealt with them so they could practice even more categorizing at home before we'd start a lesson on utilizing these types of numbers. And that's all for today.